Welcome to the 7th lecture. So, we have been discussing about the Euler's theorem last time. So, we will continue with that. So, what we saw that if we assume this matrix P to be of the form cos phi I plus 1 minus cos phi times A tilde transpose minus sin phi times A tilde cross. So, this is identical to C matrix we have been trying to prove. Okay. So, here phi is the rotation about the eigen axis, rotation angle about the eigen axis, and A tilde, this is the unit vector which defines the eigen axis. Okay, and I, this is the identity matrix. So, for P to prove this, that this is a rotation matrix, this needs to be proved. So, what we need to show that P transpose P this equal to I, this is one of the properties of the rotation matrix. Then also we have need to check that indeed phi is the rotation about the A axis. So, what we suggested last time that once we start writing this P transpose P, so enter this. So, this will turn out to be indeed as I under certain characteristic that we have to assume A cross, we have to write this A cross A is equal to A tilde transpose times A tilde times A tilde transpose minus I, and A tilde cross A tilde this equal to 0. So, I have given you the equation last time. So, in that expanded equation, if you use these quantities, so ultimately it will get reduced to I, which I am not going to prove here, because we are going to take this in the as a tutorial problem. Okay, so, if P transpose P this equal to Y, so this will also imply, as per our earlier derivation, this will also imply that P times P transpose equal to Y. Okay. Let us check that P is in this indeed the rotation matrix about the vector A. So, if we operate on A tilde by this P matrix, so we have I cos phi plus 1 minus cos phi tilde transpose minus, and this we are operating by on the vector A. So, here this will get reduced to A tilde cos phi, because this is the identity matrix multiplied by this vector A, that will give you the vector A itself. This is a scalar, so it remains as it is, and here we have 1 minus cos phi, and we will use the property that the transpose A tilde. So, you can look it like this part, this second part here, and this and this. So, if we look into this, so this is A tilde transpose A tilde, so because this is a unit vector, and therefore, this gets reduced to A tilde. So, this is A tilde, and already we have discussed that A tilde cross A tilde this equal to 0, and therefore, this term gets reduced to 0. So, we have A tilde cos phi plus A tilde minus A tilde cos phi, and this term drops out, giving us A tilde. So, this is P times A tilde, this equal to A tilde. So, this is indeed rotation about the A axis, because the A axis remains unaltered. Okay. Therefore, and now the last thing we need to find out that the trace of this P matrix is indeed the trace of the C matrix that we have used earlier. So, we will write this as, so we have written two properties, and the last one, the trace P, trace I cos phi plus phi A tilde cross. Okay. So, we can break it. So, this will be trace I, and here cos phi plus 1 minus cos phi trace A tilde transpose minus sin phi trace A tilde cross. Okay. So, this is cos phi, and trace I, this is the I is the identity matrix, of diagonal terms are 0 here. Okay. So, sum of the diagonal elements, this is 3. So, we will put 3 here, okay. And this trace A times A transpose. So, if you write here A times, this is A tilde times A tilde transpose. So, this will turn out to be a symmetric matrix whose diagonal terms will be A 1 square, A 2 square and A 3 square. Okay. And already we know that, because A tilde magnitude, this equal to A square equal to A 1 square plus A 2 square plus A 3 square, this equal to 1, and therefore, this gets reduced to 1, and we have 1 minus cos phi here in this place, and minus sin phi times trace of A cross. So, A cross is your 0 0 0, and here minus A 3, A 2 minus A 1 minus A 2 and A 3. So, the diagonal sum of the diagonal elements here, it is a 0, and therefore, this term drops out, this is 0, this quantity is 1. So, here this becomes 0, and what ultimately we get 1 plus 2 cos phi. So, the trace of P is exactly the same of the same format as the trace of the C matrix, the rotation matrix. So, in all the ways that we see that P is identical to the C matrix, and therefore, this implies that P is indeed a rotation matrix. So, this means that P is identical to C, and therefore, the C we can write as cos phi I plus 1 minus cos phi A tilde times A tilde transpose minus sin phi A tilde cross. Now, the question will arise that either we are given phi and A tilde. So, we can find out C, or either C is given, then vice versa we have to find out phi and A tilde. So, it so happens that finding C when A tilde and phi are known, and this is a straightforward process, and gives C So, find C when A tilde and phi are known. So, when A tilde and phi are known, C can be determined uniquely. However, if C is given and A tilde phi need to be found out, then there are certain problems. Which we need to discuss. Okay. Besides, we have forgotten one more thing, that we need to prove that this p tilde determinant this equal to plus 1. So, already we know that we have proved that p tilde transpose p this equal to I, and therefore, this p tilde square will be equal to okay. So, this part we are aware of, okay. And this determinant we need to prove that this is equal to 1. If we do that, only then our job is done. So, we start with this p tilde transpose, if we take the determinant of this. So, this will be p tilde and this will be determinant of phi, then this implies this determinant they are the same, okay. Transpose, taking transpose does not change the determinants, and on the right hand side we will have this as 1. So, this implies p tilde equal to plus minus 1. Now, out of this plus and minus, we need to stick with plus 1. It will be clear when you look into that, when phi equal to 0. Okay. So, this implies cos phi equal to 1 and sin phi equal to 0, and therefore, if you put these values in the P matrix. So, this will get reduced to I plus 1 minus 1 times A tilde transpose minus sin phi, which is 0, times A tilde cross. Okay. So, here this part is 0, this part is 0, and P equal to I, okay. And this implies P determinant this equal to plus 1. Okay. In this case, it is very simple. So, because there is no square involved here, P determinant equal to plus 1, and because this is a rotation matrix and its a determinant is plus 1. So, it must happen that it is a determinant, if we give different values to the pi, this phi. So, still we should get a determinant value of plus 1, and therefore, we need to neglect here the minus sign. So, therefore, so this implies that p equal to plus 1 for all other values of phi. So, this way we have proved all the requirements for P to be a rotation matrix, and already we have written that, therefore, P is identical to C, and then we have written in the format I cos phi plus 1 minus cos phi A tilde transpose minus sin phi times A tilde cross. So, this is our rotation matrix. Now, given this quantity that your A tilde and phi are known. So, if we expand this, okay, so we can find out the elements of this C matrix. So, on the left hand side, if we write C as C 11, C 12, C 13, and on the right hand side, then we will have here cos phi, cos phi, cos phi. We are expanding all the terms. This is the first term, and then plus 1 minus cos phi times A tilde transpose. So, that quantity is A 1 A square, and here A 1 A 2, A 1 A 3, similarly A 2 A 1, A 2 A square, A 2 A 3, and then A 3 A 1, A 3 A 2, and A 3 A square. So, this is your the second term, and the third term, of course, this is minus sin phi and A cross, which is skew symmetric matrix, minus A 3 A 2 A 1 A 1 A 3, and this is minus A 2. Okay. So, if we add the right hand side and compare these terms, so we can get the corresponding values. Let us say C 11. So, C 11 we need to add all the first terms. So, this will be cos phi plus 1 minus cos phi times A 1 square, and here this first term is 0. So, that put it as 0. So, this is your first term, which is cos phi plus 1 minus cos phi A 1 square. In the same way, if you write, so C T 2, this will be cos phi again the same way, plus 1 minus cos phi times A 2 square, and C 33 equal to cos phi plus 1 minus cos phi A 3 square. So, your diagonal elements of the this matrix C is known this way. It remains to find out the off diagonal terms. So, go in the same way and find out the terms corresponding to, let us say, this C 12. C 12 here, this first term, this term is corresponding here 0. So, this is 0 plus 1 minus cos phi times A 1 A 2, and here this term is plus sin phi times A 3. So, A 3 will write in the ahead. So, this is your C 1 C 12. Okay. And in the same way, C 21, if you look into this, so C 21 is this quantity. Here you have to add all these quantities. So, C 21 will be 0 plus 1 minus cos phi from this place, then A 1 A 2 or A 2 A 1, whatever way you want to write. So, let us write that way only, because these are scalars. So, it does not matter it is what sequence we write. And lastly, the last term we have to pick up. So, here C 21, this term we have to pick up. So, this comes with minus A 3 sin phi. So, this is minus A 3 sin phi. So, this way if we continue, we can complete this cycle. So, we will have C 23 equal to A 1 sin phi plus A 2 A 3 1 minus cos phi, C 32 equal to minus A 1 and C 31 equal to A 2 sin phi plus cos phi, and C 1 3 equal to minus A 2 sin phi plus A 1 A 3 1 minus cos phi. So, this way all the elements of this C matrix it is a known. So, given phi, the rotation angle about the eigen axis and the this vector A itself, okay, which is constituted of A 1, A 2 and A 3. Okay. So, we will be able to find out this C, the rotation matrix, and also we need to look in the opposite way, in the vice versa. Also we need to look into just the opposite way, that is given C find A tilde and phi. So, this process it creates certain problem and care must be taken while working with the problem. Okay. Okay, so, before we do this, let us look into or maybe we can continue with whatever we have been doing and we will return back to this problem. So, the first we have the problem here, finding A tilde and phi from C. This is my problem which we need to sort out. So, already we have seen that if C is given. So, the trace of C, trace C equal to C 1 1 plus C 1 2 C 2 2 plus C 3 3, and this we can write as delta, and this quantity we have written as 1 plus 2 times cos phi. So, C is given. So, from here what we have, if C is given, so this quantity is known. Okay. So, from this place then cos phi, this becomes delta minus 1 divided by 2. Okay. The other part we have to also look into. So, the first step is our delta, write this as C 1 1 plus C 2 2 plus C 3 3 equal to 1 plus 2 cos phi, and from there you write cos phi equal to delta minus 1 divided by 2. So, the second step is what we get, cos phi equal to delta minus 1 divided by 2. Now, what we are left with, that we have to find out the A vector. Okay. There are certain problems involved. So, we have to resolve all these problems even with the angles which will come across shortly. So, we have this C matrix, the rotation matrix, which we are writing as I cos phi plus 1 minus cos phi A tilde transpose minus sin phi A tilde cross. Okay. So, if you look into this, this is a symmetric term, this is also a symmetric term, because A tilde times A tilde transpose, this is a symmetric matrix. Similarly, I is a symmetric matrix, and therefore, this together it is a symmetric term, while here on this side this is skew symmetric term. This is skew symmetric matrix, and you must be aware of from your elementary matrix algebra that C can be written as 1 by 2 times C plus C transpose plus 1 by 2 times C minus C transpose. If we break it and add it up, so if we can check whether we have done the right thing or not. Okay. So, 1 by 2, this cancels out, times 2 C equal to C. So, this simply says that any matrix can be broken into two terms, one is a symmetric one and another one is the skew symmetric one. So, this portion this is symmetric. Okay. So, this is symmetric, while this one is skew symmetric. So, therefore, we get certain advantage from this place, that 1 by 2 times C minus C transpose. Here we will look that this term is symmetric term and this term is turning out to be the skew symmetric. So, 1 by 2 times C minus C transpose must be equal to sin phi times A tilde cross, and this implies that A tilde cross we can write as 1 by 2 sin phi times C transpose minus C. So, this constitutes our venue for finding out this particular expression A 1, A 2 and A 3, but there are certain problems involved which we need to sort out. So, we have here 1 by 2 C transpose minus C, this we are writing as A tilde cross sin phi, or either we can write sin phi here in this place. So, A tilde cross we can rub it, rub this side. A tilde cross this equal to 1 by 2 sin phi C transpose minus C. Now, if phi equal to 0 or plus minus pi or plus minus 2 pi. So, we can see that sin phi reduces to 0 and therefore, A cross is not defined. Okay. So, this is a problem that for these values we face certain problem. So, let us explore it once the corresponding cos phi when phi equal to 0. So, this implies cos phi this equal to 1, when phi equal to pi cos phi equal to minus 1, and when phi equal to 2 pi and lastly when phi equal to minus pi equal to minus 1. So, the corresponding delta value if we look into, so delta equal to delta we have cos phi we have written as delta minus 1 divided by 2. So, what happens here in this case, that if we choose the first one, phi equal to 0. So, delta this gets reduced to 1, if we choose this one, this is the second one. So, phi equal to minus 1, cos phi equal to minus 1 and then delta minus 1 divided by 2. So, this implies delta equal to minus 2 plus 1 equal to this should turn out to be minus 2 equal to delta minus 1 minus 2 equal to minus 1. And phi equal to this one we need to correct here, we have written it wrongly. So, phi equal to 1, if we put cos phi equal to 1 here. So, this quantity this is 1 equal to delta minus 1 divided by 2 and this implies delta equal to 3. So, similarly, the third one 1 equal to delta minus 1 by 2, this implies delta equal to and for the fourth one again we get this is the third one, and the fourth one is minus 1 delta equal to minus 1. Okay. So, we are getting either the value of delta equal to minus 1 or either 3 for all these values, where sin phi is vanishing. Okay. Now, for phi equal to 2 pi 0 or 4 pi or minus 2 pi and so on. So, it simply implies that suppose this is a vector and this has been rotated by 2 pi. So, this vector will again come to the same position, is not it, or either it has not been rotated. So, it remains in the same position, and if you look into the similarly for the other 4 pi minus 2 pi etcetera. So, if you look into the C, so here I times cos phi plus 1 minus cos phi a tilde minus sin phi a tilde cross. Okay. So, if you put all these quantities where sin phi is vanishing, so this quantity is 0, and for all these 0 2 pi this quantity will vanish, this will also be 0. So, this a term is vanishing, is not it. Here also this term involving a is vanishing. So, therefore, from given C matrix it is not possible to find out A. So, for this case, so this indicates either the motion has not started, this indicates that rotation has not started, or it has rotated in multiples of 2 pi. Okay. So, for this particular case where 2 pi 0, 4 pi minus 2 pi and so on minus 4 pi. So, we won't be able to find out the A vector, okay, which is very much visible from this place. Okay. For all other cases when delta is not equal to minus 1 or 3. So, for these cases we can solve it. Okay. So, for those cases it is very easy to write, because already we have written A cross matrix equal to 1 by 2 sin phi C transpose minus C. So, we just need to insert C transpose C, and phi of course, we need to we have already defined this phi. So, in the case where this phi is non-zero, sin phi is non-zero. So, this quantity is known, and the right hand side this is known, and therefore, A cross can be defined uniquely. Okay. So, certain problems are involved. So, one problem was here that we have resolved this case, for this particular case where sin phi is non-zero. Okay. So, for that particular case we are able to uniquely define it, and that you can do by writing A tilde cross. So, here 0 0 0 minus A 3 A 2, then here minus A 1 minus A 2 A 3, okay. And on the right hand side expand this by writing 1 by 2 sin phi and C transpose minus C. So, that will turn out to be you have the elements like C 1, here it will be transpose of this C 1 2, C 1 3, then C 2 1, C 2 2 and C 2 3. This is transpose of the C matrix C 3 1, C 3 2, C 3 3, and then subtract from here the C matrix which is C 1 1, C 1 2, C 1 3, C 2 1, C 2 2, C 2 3, C 1, C 3 2, C 3 3, and compare the corresponding terms. So, if we do so, so we will be able to get the quantities here A 1, A 2, A 3 etcetera. So, what we see that this A 2 from this place A 2 is this minus this. So, C 3 1 minus C 1 3 divided by 2 sin phi, okay, A 2. Okay. Similarly, A 1 we can check from this place this is C 2 3 minus C 3 2 divided by 2 sin phi. Okay. Similarly, we will have A 3, we can check from this place C 1 2 minus C 2 1 divided by 2 sin phi. So, this gives you uniquely A 1, A 2, A 3. So, your phi is defined, and also your A 1, A 2, A 3 is defined, and there are certain other problems we will of course discuss during course of time. So, what is remaining here, that we need to discuss the case where here for 2 pi 0 4 pi we have already done. We need to discuss about the plus minus phi plus minus 3 pi, this case is remaining. So, we will discuss it in the next lecture. Thank you for listening. We continue this in the next lecture.